Okay guys, we're doing factorizing by grouping terms. So that's going to be section 2.2. Okay, and this relates to the learning outcome, which says we need to be able to flexibly convert between factorized and expanded forms. Okay, so we're going to go from factorized form to expanded form. And vice versa, and the other way around. Okay, and the other way around is because it says here you have to flexibly convert between the two, and indeed we won't even understand it unless we start off by expanding. So let's expand. Let's go with the question in your book. Now I'll have to work backwards through this because I'll be looking at it here. So we'll go with, now I don't like the way they do B plus C, so I'm just going to change those letters around slightly for you because it's just easier to write it down. Let's write down A plus B by C plus D. Okay, now we can split the brackets, but splitting the brackets means you have to write it out again, and you can, which is the exact same as saying multiply A by that, 1, 2. What we cannot use here is FOIL, because, or at least FOIL is pointless because there's no like terms coming out of this. No, this is all about the fact that there are no like terms, and the reason there is no like terms is that the binomials are not like each other. They're not x's and numbers, x's and numbers. Okay, so we've unlike binomials. Okay, so we'll multiply the A in and get AC plus AD, and we'll multiply the B in. Let's use under arcs to visualize what we're doing here. Okay, so multiply the B into C, BC plus BD. Okay, and I just want to remind ourselves that we could also do this using the two-way table, because that's what they're about to do here. Okay, and like I promised, I'm going to follow the convention, the textbook way, as well as possibly showing you what I consider better variations that you'll be likely to see in the that you'll be likely to see in the marking schemes. Okay, so we're going to multiply this in. You're used to doing this. It's AC AD and BC BD. Now, so long as they, so the anything in a row has a highest common factor because of how they've been multiplied out, either row, and anything in a column has highest common factors. But there are terms that don't have a common factor, like those two and those two. So we must be aware that they could, in a nasty way, set the question up so that they have uncommon terms beside each other. Okay, but we assume when we're doing these, and every single question in your book has, the grouping is already done for you, they're already grouped, but we'll throw in a few extra questions to make sure that you're able to handle when they're not grouped as well. Okay, so the way you solve it is simply, well, this has been done for us. At least we've multiplied this out, so basically instead of starting here and here and getting this stuff, we can start in the middle and get that stuff. So let's go to this example here. Okay, in your book, so we could have started with 2AB and 2AC in the middle, and then on to the next two. So that's group 1, and this is group 2. When I'm showing you these in a moment with the other variation of how to do them, don't worry, these are not hard at all. They're very easy to do. 3cx. Okay, so what we want to do is we want to figure out what's common up here as we look down the way, and it's b, and figure out what's common here as we look down the way, which is c. Anything else? No. Figure out what's common as you look across the way, and it's 2a. When I say what's common, I'm looking for the highest common factor, and what's the highest common factor here? It's 3x. So now it's done for us. This is 2a plus 3x times b plus c. Okay, of course it doesn't matter which one comes first and how they went about that. Okay, so they've written it, I don't know, we'll always write this first and this second. The book seems to swap over and back. It's quite annoying because the more familiarity and consistency you get in your system, the better. Now with the minus, I'll just warn you, when there's minuses involved, this method isn't the best at all. It works, but it's a struggle, and it's going to be a lot of give and take, a lot of trial and error with it. So it's probably a good time I showed you a variation if we're going to do this one. And the way it works is, first of all, we don't need any of this two-way table. We just write down the question. And we take our first group, let's put a line under it, and we factorize it. Now, we know we'll end up with two terms, a binomial and a binomial. So I'm going to take out the common factor and put it here, and I'm going to take the binomial that's left behind and put it here. And finally, using the second group, we'll find out what goes in there. Okay, it's that simple. So what's in common between these? X is. Okay, so we'll put the x here. What's left behind? 3a, take away b. Now, we have to kind of associate, it's kind of obvious, which goes with which. That goes with that, and that goes with that. They could be crossed over and back depending on how they've messed around with the order. But generally speaking, it'll go like this. Now, minus divided by plus is minus. 3's cancel, a's cancel, you're left with y. And you can just use the last one to double check that everything is fine. And it is. Okay? Great. Okay, now earlier on I set up two questions. Actually, a video that didn't work out for me, believe it or not. It's not there. Here it is. Yeah, okay. So look, here's something that's been multiplied out. Actually, let's just go to the questions in the book. What did we do? We did the top one, but did we do the bottom one at all? No, I did the bottom one using the second method. And the second method isn't a different method. Okay, it's still factorizing by grouping. It's just a variation on factorizing by grouping. So let's do example 2. 6x squared plus 2a minus 3ax minus 4x. Okay, so do they have anything in common? They have 2 in common. That might be enough. So probably, as far as I know, the book doesn't jumble anything up. So with those 2 in common, we're going to create this, this, and this. So what's in common? 2. No, I have a problem. So that's interesting, actually. Yeah, it is interesting. I was wrong. The book have put in one where you have to rearrange them. Okay, So basically, if we take either of these, so basically the best thing to do when, so why am I not happy here? Because if I continue on here, I get x squared plus a, and then that won't go in there. Okay, so it's actually a good example. Okay, so I have to regroup. And if you have to regroup, there's one thing will always work. And that is swap the middle two terms. So we'll swap the middle two terms. Okay, and we will take out what's common, which is 3x, which makes us think, well, there's a lot more factoring going on, so we're on the right track probably. So we 3x has come out, which means 2x is here. Why? 6x squared divided by 3x, 6 over 3 is 2, and x squared over x is x. And 3x has come out, so we have a minus factor. That can be tricky, and a. Okay, now we have to figure out which goes with which, so clearly that goes with that, and this goes with this. So how many times does minus a go into plus 2a? Well, plus divided by minus is minus. The a's cancel, and you're left with 2. Okay, and we can double check that everything is fine now by getting 6x squared minus 4x minus 3ax and plus 2a. Okay, so that was a tricky one, and I've kind of shown you everything you need to know to do for us to do any of these. Okay, they're quite easy, or at least the system works very, very well. Okay, I'll do a bunch of these on the even side, and I'll leave you do the odd side. But remember, in each case here, you're pausing the video and you're doing it yourself as well. Okay. So in question 2 here, 3x times 2a minus b. It's kind of half done for us already, which might seem a little bit confusing in a way. So basically, this is like your split brackets. You have your 2a minus b, and you have your 3x minus 4. Let's just bring the answers into this as well. Now you shouldn't, it's quite unnatural to check answers in that in the textbook you won't be able, in an exam you won't be able to, but you are able to multiply it out. But nevertheless, I know you like checking answers in the back of the book, and we're in section 2.2, and that was question 2. So let's see how we're doing. Three x minus 4, 2a minus b. Correct. Okay. And I can do the next one on the fly. By looking at it, it will be 2x plus b and 5y minus z. Okay, we can check now question 4 there, and it's done. Okay, now something, at least it's all positives. So question 6, we have a squared plus ab plus ac plus bc. Okay, it looks like everything is kind of set up for us okay at the moment. So let's write down our two brackets, take out the a, and you've a plus b, divide that in there and put your answer over here, plus c. Okay, check it. Question 6, a plus c and a plus b. Great. Okay, question 8, ab plus ac minus 5b minus 5c. So even with these two terms, it creates 3/4 of your answer. Take out the a, you have b plus c, put that in there, you have minus 5, a take 5, b plus c. Question 10, ooh, squares and letters and numbers and all sorts of things, but not very difficult, to be honest. This is a common 3 and a common 4. It's not going to be too tricky at all. 3x squared minus 3xz plus 4xy minus 4yz. Take out the common 3x, leaving x in. There's a minus here. Z. Associate that with dividing in there, giving you plus 4y. Now, which leads me to make a few kind of sophisticated points. This has two minuses in it, and it doesn't tell you an awful lot. It tells you there can either be one or two minuses, because when there's one minus there'll be two negative terms, and when there's two minuses there'll be two negative terms. Okay, it's really to do with where they're at. If this was minus and this was plus and they were grouped correctly in order, then you'd end up with a minus minus, but you don't have to worry about that much. Okay, so that was that 110. I'll do just a few more just to see what comes up and give you confidence in this method. I might just speed up though, which sounds appalling because I know it's school maths. However, you do have pause. Okay. 2ax minus 6ay minus 3x plus 9y. Out comes 2a. What stays inside is x minus 3y. That will divide in there to give minus 3. And that works. Okay. Do 20. 7y squared minus 21by plus 2ay minus 6ab. Take out 7y, leaving, and in the second factor the binomial will be y minus 3. 7 into 21 is 3. It's a negative over a positive, so negative here, and the b's are gone, the y's are gone, so you're left with b. Now that goes into that plus 2a times, let's check that, question 20, 7y plus 2a times y minus 3b. I think we've done enough. We'll go on to the next section. As always, so the next section here will be, the next video down will be the difference of two squares. As always, I'll see you in the next one.